Now, the second learning objective is to learn how to use a permutation formula. First of all, what is the permutation? Permutation is an ordered arrangement of items that occurs when no item is used more than once. Second, the order of arrangement makes a difference. For instance, suppose here's one example of like permutation. Say suppose we have 3 students to form a committee, and the committee has a chair, secretary, and treasurer. Okay. Say suppose Amy is say chair, and say Bob is the secretary, and say Cat as the treasurer. Now this is one permutation. This is one permutation. What is the permutation? An order arrangement, right? So now another permutation could be Bob be the chair, Amy be the secretary, and Cat be the treasurer. So this is another permutation, which means an order arrangement of these 3 persons. Okay, what is a permutation? Permutation is just ordered arrangement. Now, how many possible permutation of R items are taken from N items? So in this case, actually we have 3 students taken from 3 students. If we have say suppose 10 students, okay? Suppose we have 10 students. And then suppose we choose 3 students and to form this committee, then how many possible ways to form such committee? And in this case, R will be 3 because 3 committee members. Taken from N will be 10 in this case. How do we compute the number of possible permutations? It's N P R, or the P of NR. To compute that, it's going to be n factorial divided by n minus r factorial. And more calculation friendly version will be this one, n times n minus 1 times and so on and so forth until the last one is n minus r plus 1. Please note that this will be a total of r number, a product of r number, so product of r number of numbers. Okay, there are r number of numbers here. Now let's do some exercise. Okay, so let me zoom in. Okay, all right, so the first example, how many permutations of letters are there in the word in this word? Computer. So that means again, permutation means the rearrangement, any arrangement of those letters, right? So we want to say if you shuffle these letters, you get a new arrangement. So we want to see how many possible permutation of the letters are there. Now, first of all, we have eight letters here. So here, 8 letters. Okay, 8 letters. And then we want to permute them. That means rearrange them. So how many ways are there? According to our the formula is going to be 8 permute 8. Okay, 8 permute 8. Or sometimes this is in your calculator, you see this NPR, that symbol, that's the permutation. Or sometimes we have this notation, the permutation of 8 subject. You choose 8 in this case. We just use all the letters. And how do we actually compute it? You're going to begin with 8 times 7 times 6, and so on and so forth, down to 1. Okay, basically which is 8 factorial in this case. 8 factorial is pretty big. It's actually 40,320. So there are these many possible permutations using computer. Now this another way of looking at this is this. You remember in the last learning objective, we learned how to use the multiplication rule or the fundamental counting principle, right? So in this case, because we have 8 letters, so there were 8 little spaces, okay? So how many ways to fill in the first one? So there were 8 to choose from, so it's going to be 8. Step 2, find a letter to fill in the second one, right? 1 is used, so you're left with 7, so the next one will be 7, and so on and so forth. The 2 letters are used, so the next one you have 6 to choose from, and so on and so forth. So 3, 2, 1, which is 8 factorial. So this is using the like counting principle perspective. You can do that. Now, next, how many ways can the letter in the word Huang be arranged? So there were H-U-A-N-G, there were 5 letters, right? So you can do it quick. It's going to be 5 factorial, which is 120. Now, let's look at some variation of this type. How many ways can the letter in the word Huang be arranged if A-N, so the A-N, this A-N, must remain next to each other in its order. You cannot use N-A, it has to be A-N as a unit. I strongly encourage you, pause the video, think about it before you resume. Now here, you can actually treat this as a special letter. This letter is just A-N, A-N. So therefore you can count, okay, we have 1, 2, think of this as a whole, 3, 4. You're going to permute this 4, okay? So therefore, your answer would be, okay, we'll just permute 4. 4 factorial equals 24. Okay, 4 factorials. Now, what if I change this wording? Like say, I'm going to just say, A-N must retain next to each other, but does not have to be in order. In other words, A-N is okay, N-A is okay, but they have to be next to each other. So in this case, so if I change, if A-N must be adjacent, okay, adjacent, doesn't have to be in a certain order, then you can just think about, I just simply double, like this one, 8 has to be A-N, which is 24. N-A is allowed, I just double it because you just double it, right? So in this case, it was just 4 factorial times 2, which is 48, okay? So this means can be N-A or A-N. So that's why we double it. All right, let's move on. The next learning objective is we're going to introduce combination. A combination of items occurs when the items are selected from the same group. No item is used more than once. The order of the item does not matter. Okay, the difference between permutation and combination is the order, whether the order matters. So previously, we talked about selecting committee, right? A being chair and B being the secretary is different from B being the chair, A being the secretary. So that order matters. That would be permutation. Now, when combination, for combination, the order doesn't matter. For instance, if I say, okay, from 10 students, okay, 10 students, if I invite 3 students to a party, so in this case, like A, B, C being invited is the same, considered as the same as B, A, C getting invited. So the order really doesn't matter in this case. So that is the combination. The number of possible combination of if all items are taken from n items. So in this case, say suppose 3 students are taken from the 10 students, all will be 3. n will be 10. So we use n choose r or this notation, but we use this notation more often. So n choose r, which is the binomial coefficient, right? Binomial coefficient. If you remember, that would be, there are two versions. One is n factorial divided by r factorial, and also n minus r factorial. The second one would be n. N times n minus 1 times n minus r plus 1, okay, divided by r factorial. So two versions. Now, in a group of 11 persons, how many ways to choose 3 members to work as a team? So we, choosing, this is choosing 3 from a group of 11. So the order really doesn't matter. These 3 will form a team, right? So therefore, I should use the combination. Therefore, I'll just say 10, 11 choose 3. That's what I'm gonna find, which is equal to, I would use that one. That one is a little more calculation friendly. So I'll just say 11 times 10 times 9, stop, because you already have 3 numbers. You have 3 numbers. The bottom is the 3 factorial, so 3 times 2 times 1, right? And let's, always there was some cancellation here. So cancel the 3, cancel the 2. So we have 15 times 11, which is 165. Okay. Of course, if you use the other version, which is the 11 choose 3, you have 11 factorial, 3 factorial, 8 factorial, and I would still expand 11 times 10 times 9 times 8 factorial, so that I can cancel the 8 factorial right there, right? Which is going to be the same as this result. Okay, so next, 6 people are needed to form a committee, so there are 6. In how many ways can these 6 people be chosen from a group of 20? So again, pause the video if needed, give a try, and then here's the, form a committee. It doesn't say any detail about this committee, so we'll consider that as the order doesn't matter. So in this case, we just say, okay. So we just want to see how many ways to choose 6 people from 20 people, right? So 20 choose 6, which will be, okay, I'll use the 20 times 19 times 18. You should pause and ask yourself, when should you stop, right? Like what's the last number that you should multiply, then you stop. So 20, 19, 18, 17, 16, 15, then I'll stop because there are 6 numbers here now. That's the 6. So and then 6 times 5 times 3 times 2 times 1. Oh, missing the 4. So there's a 4 there, 4 times. Okay, now that then there gotta be a lot of things to cancel. Like 4 times 5 is 20. Cancel out with this 20. 3 times 6, which is 18, right? Cancel the 18. And then this 2 cancel out with the 8. So eventually, we have the following: 19 times 17 times 8 times 15. If you use your calculator, this should turn out to be 38,760. And by the way, in your calculator, okay, you should use the probability, this little button, and then choose this this one, and choose R, and then provide the M, provide the R, which is 20 and 6. You should be able to get this one. All right. While we're here, let's finish the objective number 4. distinguishing between permutations and combinations. For each of the following problem, explain if the problem is one involving permutation or combinations. Just ask yourself, does the order really matter? If the order matters, then it's going to be permutation. If otherwise, it's combination. So how many ways can you select 2 free DVDs from a list of 15 DVDs? So you just get 2 DVDs. Does the order matter? Does the order matter to you? I don't think so, right? The order doesn't matter. So this is going to be a combination. So for instance, DVD A, movie A and B selected is the same as movie B and movie A selected. So they are considered the same. They are not so order doesn't matter. Okay, order doesn't matter. So therefore, it's going to be combination. So we find 15 choose 2, which is 15 times 14 stop divided by 2. So which is 14 times 7, which is 105. Okay. In a race in which there are 50 runners and no ties, okay, 50 runners. How many ways can the first 3 finishers come in? So now this one, no ties, therefore the first 3 come in, the order does matter. So here order matters. Then we use this 50 times 49 times 48. Okay, whatever this number is, that's how many ways. So I'm gonna do a quick calculation. 50 times 49 times 48. This is 107,600 different ways. How many arrangements can be made using 4 of the letters of the bride? Well, notice none of those digits are repeating. They're all different letters, right? 6 different letters. If no letters is to be used more than once, so we're using 4 of the letters. Okay, so therefore this is definitely permutation. So how many ways to fill in the first one to form a four letter arrangement? So there are 6 to choose from. So you're gonna choose 6, and then the second one, 1 letter is gone. You have 5 to choose from, and the third one you have 4 to choose from, and the last one you have 3 to choose from. So this is so it's gonna be 360, I believe, because this is 30, this is 12, so 360. So this time the order matters, right? Order definitely matters. So order matters. It's a permutation. Now lastly, an election ballot asks voters to select 3 city commissions from a group of 6 candidates. In how many ways can this be done? So we just select 3 from group of 6. The order doesn't matter in this case. So order does not matter. So therefore we use combination. 6 choose 3, which is 6 times 5 times 4 stop divided by 3 times 2 times 1, and which is 6. So you can cancel that. It's equal to 20. So this is it for this lesson.